All right, welcome to tonight's video on the discriminant part of the square root, which is the b squared minus 4ac, or sorry, discriminant part of the quadratic formula, which is the b squared minus 4ac. It's the part under the square root. There are three things that could happen for the discriminant. It could be negative or less than 0, which means you have two complex roots, which means you have an I. If it's greater than 0, then you have two real roots, which means obviously they're not imaginary numbers. And then if it's equal to 0, you have one real root, which is what's called a double root. So without solving the equation, we could determine the nature of the roots. So you need to know what A is, you need to know what B is, and C. In this case, it's 1, 5, and negative 12. So if you go B squared minus 4AC, you get 25 plus 48, which in this case is 73. That means there are two real roots. You don't necessarily need to find what they are, you just know that there's two real roots. All right, so now we're going to look at solving equations using any method. Okay. There's three methods. Remember, you can factor, if possible, completing the square and quadratic formula. The first method, obviously, we would want to try is factoring. So let's look. Does it factor? So are the factors of negative 4 that add to 3? And the answer is yes. The factors are 4 and negative 1. So you can go x plus 4 and x minus 1 equals 0. And then you just solve. So you get x plus 4 equals 0 and x minus 1 equals 0. So x equals negative 4 and x equals positive 1. Those are your two answers. If you look at this one here, this one, if there's a quantity squared, you're going to do completing the square. Now, you don't have to do a whole lot other than divide by 4 to get the squared by itself. And then take the square root of both sides. And remember the plus or minus. So you get x minus 1 equals plus or minus the square root of 5. Add 1 to both sides, so you get x equals 1 plus or minus the square root of 5. The third type of equation here, remember, this rational equation, so remember you multiply by the LCD, right? So the LCD here is t minus 2 times t minus 1. Multiply each term by that. So it's t squared minus t. And then when you distribute here, you get 2t squared minus 4t. Here you need to FOIL, so you get t squared minus 3t plus 2, and then you multiply by 6, so you get 6t squared minus 18t plus 12. Now move everything over to, well, combine like terms first, so 3t squared minus 5t. And then move the 6t squared over. Actually, let's pause that for a second. We're going to move the 3t squared this way to keep the t squared term positive. So you're going to have 3t squared, and you're going to add 5t. So you have minus 13t plus 12. So then you see if you can factor. Well, are there factors of 36 that add to negative 13? And the answer is yes, there are. Negative 9 and negative 9 and negative 4 don't, negative 9, negative 4, sorry. So when you factor, you get 3t minus 9 and 3t minus 4 equals 0. Now remember, you can divide by 3 here, so you get t minus 3 and 3t minus 4. When you set them equal to 0, you get t equals 3 and t equals 4/3. So those are your two answers. Now, if you didn't factor it correctly, you could always solve by the quadratic formula. Because remember, a quadratic formula works anytime, but you always want to see if you can factor it first. Now the last problem, it says find k if the following equation has a double root. So you want to basically know what you put in for k that makes this a double root. So you do the a, b, and c. And remember, if it's a double root, b squared minus 4ac equals 0. So you substitute in the b squared, the a, and the c, and you figure out what makes it equal to 0. And then you solve for k, and you get two answers at the end that make it equal to 0. And that's how you do that. I hope this video was helpful, and I look forward to seeing you guys next time. And if you have any questions, let me know. All right, have a good evening.